factor pairs. And as we discussed before, factors are numbers which go into another number. Let's have a look at some examples. Okay, so we have here an array. Alex is making arrays using counters. What calculation is represented in each array? Here we have 18 counters, but it's a row of 1. And we can even see that this box is smaller, so it must be a single digit number. So this is 1, and then we have 18 going across, so 18 columns. So what would I write in here? Well, it would have to be 1 times 18, okay? Because 1 times 18. Now this one equals the same amount, 18, but this time you have 2 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So we know that 2 times 9 equals 18, okay? 2 and then 9 across that way. And also, we now know that 1, 18, 2 and 9 are all factors of 18, okay? They all go into 18. They're all whole numbers which go into 18. Right. Okay, they're numbers which go into another number. So as I said before, 1, 18, 2 and 9 all go into 18, which make them factors of 18. But we'll see more, you'll understand more as we go through. Here we're going to be looking at more factors of 18. So we have a row of 3, we have 3 rows. In other words, I put 3 in here. What number goes in here? 6, good, someone knows their 6 times table. 3 times 6 equals 18. So that also means that 3 and 6 are both factors of 18. Yeah, so far we've got 6 numbers which are factors of 18. We've got 1 and 18, of course, 2 and 9, and then here we've got 3 and 6. Use your answers from part A to help you write all the factors of 18. So can you remember all the factors? So we have 1, 18, 3, 6, 2, and 9. Yeah? They're all the numbers that go into 18. There aren't any other ones. So there's 6 numbers. Okay. Use counters to make arrays and find the factor pairs for each number. Well, you haven't got counters. Maybe you have at home, but we'll have to just do this in our head. Yeah, you can draw it. Of course, you'll need quite a bit of paper for this task. Probably you won't be able to do it on the worksheet. But in your head, what numbers go into 12? 6 and 2, because 6 times 2, so 6 and 2 must go in. What else? Sorry? 12 and 1, that's the easy one. You should always know that one, yeah? 1 goes into every single number. And then, of course, the number itself. 1 and 12. And what else? There's one more. 4, good. And, of course, that means that 3 must go in as well. So 12 has 1, 2, 3, 4, 5, 6 numbers, which are factors of 12. Okay, 15. What numbers go into 15? Yep, 15 itself. And therefore, we have 1. And then 3 and 5. Okay, is that it? That's it, isn't it? Yeah? Because 15 is not an even number, so we can't put 2 into it. So that's it. Right, 24. Now 24 has a lot, or quite a few. Who can give me some factors of 24? 12 and 2, there we go. Good. What else? 8 and, of course, 3, yes. Good. Yeah, somebody said 1, so of course that means 24 must as well. Now, if 8 goes into 24, that must mean 4 goes into 24, right? How many times does 4 go into 24? 6, good, because 8 goes 3 times. So 4, which is half of 8, must go twice as many times. 6. Now, I think that's it. Yeah, we can't do anything else. Okay, which of the numbers has the most factor pairs? Which one has the most? 24, of course, yeah, good. Complete the factor bugs for 45 and 64. Right, so 45, what number can go into 45? 9 and 5, so I'll put 9 here, say, and 5 here. Is there anything else? Yeah, I'm not sure if we are supposed to do that. I think we just put all the numbers that go in to 45, yeah? So that's it, right? Nothing else. Let's move on to 64. So we've got 4. Does anyone know how many times 4 goes into 64? 4 and 16, so 4 goes into 64 16 times, yeah? Now, some people might have trouble working that one out, so let's show you how it can be worked out. We know that 10 times 4 equals 40, yeah? And then, but we've got 64, so we need another 24, right, to make 64. So we need to do this. How many times does 4 go into 24? 6, right, so that's how you get your 16. So I'll put the 16 here. Oh, it seems to have a tail here at the end. 2 and 32, good. Right, is there another number which goes into 64? Well, I'll give you a clue. 32 is in the 8 times table, so 8 goes into 64 as well. Okay, find all the factor pairs for the number 72. So what makes 72? Actually, I don't need to write 72. 9 times 8, so I'll put 9 and 8. What else? 6 times 12, good. Yep. Oh, I just need to let this person. So we can see that 72 is an even number, which means it can always be divided by 2. Yeah, so what is half of 72? Well, what's half of 70? If you know your 7 times table, 5 times 7 is half of 70, which is 35. Okay, and then we add the 1, because it's 72, not 70. So we get 36. Okay, 2 times 36 equals 72. What else is there? Well, what's the easiest one? First of all, we can do 1 and 72. Yeah. There we go. Okay, and now one thing you can do is you can look at these numbers. So we've got 80, we've got 12, we've got 36, and we can tell that 4 must go into 72 because 4 goes into all of these numbers, right? So 4. But how many times does 4 go into 72? Right, well, that's a tricky one to explain, but we can look at it like this. 10 times 4 equals 40. So if we did 20 times 4, 80, right? But of course, we've got 72, right? So 80, take away 72, equals 8. So we've got 8 left over. So 8 divided by 4 equals 2, right? So the thing is, with our 80, we've got too many 4s. Yeah, so the answer is 18. 18 4s go into 72, yeah? Because 20, you have 2 4s too many. Okay, so let's count. We can go in order. We've got 1, 2, we haven't got 3, but 3 must go into 72 because 9 goes into 72, right? So how many times does 3 go into 9? 3 times, yeah, so 9 divided by 3 equals 3. So it goes 3 times, okay? Yeah. Now the reason I'm asking that is we know that 9 and 8, if we times them, they go in. What's 3 times 8? 24. Right. So 3 times 24 will give you 72. Okay? Because we know 9 and 8 go in, so 3 must go in, but 3 is 3 times less, so we need to multiply 8 by 3. Okay? I think that might be all the numbers. We've got 1, that's 2, 2, 3, 4. We haven't got 5. 5 can't go in because it's not got a 0 or a 5 on the end. 6, 7. Can 7 go in this number? No, because we know 10 times 7 is 70, so the next number will be 77. 8, we've got 9, we've got 10 can't go on because there's no 0 on the end. 11 can't because it's not 77. 12, we've got 13. It's unlikely, but we can test it out. So we've got 13. What is, let's do 6, let's do 5 times 13. So we've got 50 here, if we do 5 times 10. And then, yes, we'll have 65. Well, the thing is, if we add another 13 to that, we'll have 78, so that doesn't work. So it can't be 13. 14, we haven't got 14, have we? No. We'll try it out. 14 times 5, again. What's 5 times 10? 50. What's 5 times 4? 20, so we get 70. So if we did 6 times, yeah, it wouldn't work because it would be 70. Okay, so, yeah. Okay, so I think these are the only numbers which are factors of 72. Right? Let's move on, because otherwise it'll take us ages if we work out all the numbers, but if we can't see any jump out at us, then I think that's good enough. Are these statements true or false? 8 and 2 are both factors of 10. So is 8 a factor of 10? No. You can't, yeah, 10 divided by 8 is not possible. Yeah? 10 divided by 2 is possible, but the thing is they're saying 8 and 2, so it has to be false. 5 and 50 are factors of 50. Is 5 a factor? Yes, 5 goes into 50 10 times, and 50 goes into 50 1 time, so that's true. 25 has only 3 factors. Let's see. Right, yeah. That's right, yes. So, because we know that, okay, we know that 25 and 1 go in, don't we? So we know that 25 and 1 are factors of 25. But then we also have 5. And the thing is, you have to times 5 by itself to get 25. 5 times 5 is 25. So there's no, it's not a pair, as it were. These two are a pair. But the other number you multiply it by is 5. So it is only 3. All the factors of 15 are odd. Well, what are the factors of 15? 15, 1. What other factors are there? Well, there's, what goes into 15? 3 and 5. Is there anything else? No, I don't think there is, okay? Because it's not an even number, so you don't have 2. So all of the numbers are odd, that's true. Okay? So that should make more or less sense. The bigger the number, the more factor pairs it has. Use examples to show that Dexter is wrong. Right, so what you need to do is to think of a prime number. Now, a prime number is a number which can only be divided by 1 and itself. In other words, 3 is a prime number. 7 is a prime number, because with 3 you can only divide it by 1 and 3. With 7 you can only divide it by 1 and 7. Okay, 9 is not a prime number because you can divide it by 3. So the next one up is 11. That can only be divided by 1 and 11. Okay, the next number up is, do you know? Well, it's 13. Yeah, that's the next prime number, 1 and 13. Okay, 14 can be divided by 2, so you can't have any even numbers because they are already divisible by 2. Right? 15 can be divided by 5 and 3, so that's not possible. 16 is even number. 17. Okay, again, 1 and 17. And you see the prime numbers can keep going up. Yeah? So it doesn't necessarily mean, do you know what the next one is? Good, 19, well done. So it's 1 and 19. Okay? You can keep on going up forever. Yeah, the numbers get bigger and bigger. It might be harder to find prime numbers, or they might get, the gaps between the numbers might get larger as you go up. But otherwise, so we can't have 20, we can't have 21 because that's in the 7 times table. 22 is an even number. What about 23? 23. Yes. So you can see we still keep finding prime numbers as we go up. Okay? You can go up forever, and you'll always find prime numbers. So yeah, so we've shown that this 23 has got, so let's keep going. So we can't do 24, that's even. 25, 5 times table. 26 is even. 27 is in the 9 times table. 28 is in the 7 times table. 29, what is 29 a prime number? Is there any numbers which go into 29? No. So 29 is also a prime number. Okay. And then if you want to give ones which have a lot, so example, because he's arguing that if the number is big, then it should have a lot of factors. So, well, I think what you can do is you can demonstrate that high prime number. So you could give the example of 29, that's fairly high, only gives you 2 factors. And then we can choose a number like 8 has quite a few factors, or 12, even more. Yeah, maybe I'll choose 12, which is a lower number, obviously, than 29. So 12, number 12 has 1, and it has 12, and it has, what else? Well, it has 4, it has 3, and it has 2, and it has 6. Okay? And then if you do a number like 24, which again is lower than 29, that has quite a few, doesn't it? So it has 12, 2 and 12, 2 times 12. Obviously, it has the 1 and the 24. What else does it have? 4 and 6. Yeah. Okay, and then it has 3. How many times does 3 go into 24? Well, it goes 8 times. Okay, so you can demonstrate that these numbers, even though they're lower than 29, they have a lot more factors. So it isn't necessarily true. I can see why he thinks that, because obviously the larger a number, it's more likely that more numbers will go into it. So he's kind of true, but it isn't true for every single case. So yeah, those are the examples. I was comparing a prime number or a high prime number with a lower one. So actually you don't need these lower ones on there. I was just doing that so we can go up in order. So you'd compare a high prime number with another number which has many factors. And this, numbers which are divisible by 4, 8, they often have quite a few factors. Right, Tommy is finding factors of 12 and 18. 12 and 18 have the same number of factor pairs. Is Tommy correct? Okay, well, actually, we just did the 12 one, didn't we, here? 1, 12, 4, 3, 2, 6. Are there any other factors in 12? No, so that's 1, 2, 3, 4, 5, 6. 6 factors. Oh, I've got my rubber on, okay. 6 factors. Okay, and then I'll do 18 here. What numbers go into 18? Well, similar numbers to 12. Yeah? 3 times 6. Okay, is that it? Oh, I didn't put a comma here, so it looks like 36. Whoops. Okay, 3 times 6. Yeah, 4 doesn't go. So, is it the same? Looks like it, yeah. 1, 2, 3, 4, 5, 6. There we go. So when you explain your answer, you'd just draw out this 12 and all its factors and 18 and all its factors. Okay. Find two numbers with the same number of factor pairs. Okay, so what you can do, as I mentioned before, which makes it very easy, is you just look for two prime numbers. So we've got 29 and 7, because they will both have two factors. That's the easiest way of doing this, if you just choose two prime numbers. So you can have 3 and 7. They both have the same number of factors, because 3 is divisible by 1 and 3, and 7 is divisible by 1 and 7. The minute obviously there's other ways you can do it, but it gets a lot more difficult to figure out. Yeah, if you have to work out all the factors. The easiest way is just to write two prime numbers. It's a bit of a cheat, really, but yeah. Otherwise, you need to work them all out, and it takes a lot longer. You can do it that way if you want. Class 4B is having a sports day. There are 36 children in the class. The children need to be in equal groups. What group sizes are possible? So you're figuring out basically what all the factors of 36 are. What are all the factors of 36? Anyone? 36? 1. That'd be quite a funny group there, wouldn't it? If they're all in groups of 1. But anyway, that's fine. They didn't say how big or small the groups need to be. Yeah. 2 times 18, so you can have groups of 2 or 18. Good. 3 times 6. What? 3 times 6? That's 18, isn't it? But you're right, that the 3 times table goes into 36. How many times does 3 go into 36? Well, what's 10 times 3? 12. Yeah, because 2 more 3s. Okay, well, if 12 goes into 36, then 4 must go into 36, because 4 goes into 12. And also, if you know your 4 times table. What's 10 times 4? 10 times 4 is 40. So how many times, if it's 10 times 4 equals 40, how many times does 4 go into 36? 9 times, right? Okay, so we've done 1, 2, 3, 4, 5 can't go. Whoops. Can 6 go? I think so. And the reason I know this is 5 times 6. Yeah, 6 times 6. 5 times 6 equals 30, then another 6. So we've got 1, 2, 3, 4, not 5, 6, 7. No, because that makes 35. 8. Can 8 go into 36? No, because 5 times 8 is 40. Then we're on to 9. We've got 9. 10 can't go. 11 can't go. 12, got 12. 13, no. Okay, I think that's it. Right, we better move on, because I want to make sure that everybody understands number 9. Rosie is investigating factor pair. 6 is a perfect number, because when you add its factors together, apart from itself, they equal 6. Yeah, when you add up all the factors apart from 6, then you get 6. So what they mean is if you add 1, 2, and 3, and you get 6. So you add all the numbers up apart from itself, you get 6, right? Let's try then. Well, of course we can't do it with 7 because 7 is a prime number. Let's try it with 8. Okay, 8. So what are factors of 8? Well, of course we've got 1, 2, 4, and that's it, right? Well, yeah, that doesn't work because that gives you 7. Let's try 9. Yeah, this is the only real way of being able to work it out. 9, factors of 9. So of course we've got 1, not 2, 3. Anything else? No, that's it. Okay. We can have a look at 10. 10. So we've got 1, 2, and 5. Doesn't work great either, does it? Yeah. So that one's a no-no. Let's try, because 11's a prime number, so we need to move on to 12. How about 12? I think we might have better luck with 12, because there's more numbers which go into 12. So first of all, 1. Then, what else goes into 12? Well, 2 and 6. What else? 4 and 3. Right. So we add these up. And I'm just putting the plus. So, no, it's too much. Yeah, now we've gone too high, so that's the opposite problem. Okay, because we know 6 plus 4 is 10. No, we need to find what the next perfect number is. We need to keep looking. Okay, so we said no to 12. 13 is a prime number, so we can't use that one. 40. Right, what are factors? So we've got 1. Well, there's 2 and 7. And I think that's it, right? Yeah, okay, well that's 10. 1 is 10. So that doesn't work. 16, we've got, should we try 15? I don't think 15 will because there aren't that many because you've got 1, 3, and 5. Well, that won't work because that'll give you 8. That equals 9. No, we tried 9. So the next one was 16. So we've got 1, 2, right? How many times does 2 go into 16? Goes 8 times. Okay. And so how many times does 4 go in? Well, it goes 4 times. Okay. No, we went off because it's 10. 2 plus 8 is 10. 14, 15. 1 off. We're very unlucky. Let's try 20. Okay, so 1, 2, 10, 5, 4. No, that's too much because we've got 2 here. Okay, there's not much time left. I'm trying to desperately get the number. 24. Yeah, I have a good feeling. Oh, I don't know, actually. I'm already looking and it's like, oh, no, it's too much, isn't it? This one's too much because 4 plus 8 is 12. 12 plus 12 is already 24. So then if we add those, then it's too much. 24 is too much. 25 is going to be too little. I already know that because you've only got 1 and 5. 26, let's try 26. Yeah, 1 and 2. Don't think 3 goes in. There, 4 doesn't go in. Well, 2 times what makes 26? 2 times 13, right? Yeah, there's nothing else. That's it, right? 28. So what goes into 28? Well, 1, 2, 14, 7, 4. Good. Is that it? I think that's it. Let's try adding them up. I beg your pardon. It's 3 here. So yeah, it's correct. Right. Now you can all go.